DevOps lifecycle. Okay, so we have already discussed this in the basic discussion of what is DevOps and how the various slides of DevOps. We have discussed that. So generally, so what we see that our topic is Kubernetes. Okay, when something has been deployed using or packaged using Docker. Okay, so there is some build, there is testing, then release, and finally we have to deploy it over some environment. And that environment is on Kubernetes. That is some orchestrated environment, whether that orchestrated environment is hosted over AWS Cloud or Google Cloud or your Azure Cloud. Doesn't matter, whichever cloud it can be. It can be a SaaS application, like everything is hosted by AWS, like EKS, okay, or AKS for Azure, or GKE for Google Cloud. So that can be done, or you can use your own cluster. You can create your own cluster and create your uh, entire Kubernetes orchestration on your own in your own servers and all this without taking the help of cloud-based or cloud-hosted clusters. Okay, so if you are
Sir, your
doing with
voice
a
is
cloud, like
breaking.
my voice is breaking.
Like,
Oh,
yes,
okay,
we were
okay.
like,
Just 1 minute. I will like to. Is it breaking a lot? So I will do one thing. Just give me 1 minute. Hello. Is the voice more or less clear now? Or is it still breaking? Hello.
it's good now, sir.
Is it better now?
Better, sir.
Okay. So the network is maybe network is a bit weaker. Sometimes it does, but I have a full-fledged router. Sometimes it still doesn't work that nice. So what we were discussing is that we are going to study Kubernetes. It is after we have deployed our application over into an infrastructure hosted with Kubernetes. So it can be the infrastructure can be hosted over cloud, can be AWS over EKS, Elastic Kubernetes Services, EKS, Elastic Kubernetes Services. So most of the Kubernetes services are provided from the cloud. We have to do minimal of our own way customization, but we can also do entire thing on our own using, our own way of establishing our Kubernetes cluster on which the application will be deployed as microservices. We will come to that discussion. So it is in the operate phase, or in the DevOps cycle of operate, the Kubernetes takes its place. Like Terraform, which will provision the architecture, the Ansible, which will manage the configuration management tool, and then Kubernetes will provide all the services necessary to maintain the health of the application, performance, and whatever. So, any questions before I move on?
Sir, is it important to use all the tools?
No, very good question. It is not important to. So there is basically a thumb rule that in the entire all these phases, as we have discussed in our DevOps discussion earlier, out of all these phases, if you are conversant with one of the tools in each of the phases, you are done. So basically, we say how many? 1, 2, 3, 4, 5, 6, 7, 8. So basically monitoring, we can leave it for our operations team to handle, but because we generally, DevOps guys are not involved into monitoring, but it is good that if you can at least know Nagios or Splunk or Datadog, any one of them will do. But one each from the rest of the 7 phases, if you know the tools, the DevOps tools, that will be the best. Okay, along with your knowledge on Linux
So
and
what will be the minimum criteria to deploy Terraform or like Kubernetes?
sorry, which one is? Can you come again?
Like if we have a project, what will be the minimum criteria? Like I need these many services and these many operations should be handled by Kubernetes. Like how do we choose? Like should we go for Kubernetes or not?
Kubernetes is basically your service management mesh. Like it's a if you have a mission critical application and it is basically based on your microservices, okay, your application, there are hundreds of functions based on microservices, then it will be advisable to put them into Kubernetes because, and the Kubernetes will be hosted either on the cloud or on your server, on your on-premise or in your data center. It depends on your architectural preference by the architect, or it can be over the cloud. It depends on the company's policy. Now, if that is so, because you need to automate many things and that automate the deployment as well as maintenance of the application over, it will be preferred to use Kubernetes. So the architecture can be implemented through Terraform. The configuration can be managed through Ansible. The application deployment can be based on Docker. The version control is managed by Git. Okay. Uh, the build is done through Maven or Ant or Gradle, whatever the build architecture is. It can be, if it is .NET application, it will be some other build tool. Okay, the testing tools can be automated through using JUnit or Selenium. And the most important part, this entire thing can be automated over a CI/CD pipeline that we have already discussed in the previous 2 sessions of this internship sessions. Okay, so one of the pipelines you need to know how to automate. So it can be Jenkins, it can be GitLab, it can be Azure DevOps. So the most preferred tool nowadays is Azure DevOps, coming from the house of Microsoft. Okay, Azure DevOps.
So
So
what
that is a
about Git
CI.
actions, like GitHub actions?
GitHub. You're asking about the GitHub,
So GitHub action for CI/CD deployment.
the actions of CI/CD pipeline.
Yes,
So
sir.
the
GitHub gives the GitHub action to like deploy the CI/CD pipeline. Like you can deploy your workflow there.
yes, yes, but those are all the discussions that we already had conducted earlier. Okay, how these are integration, how you will integrate Git over the pipeline, because Git is nothing but a version control tool where the developers will put on their code. Okay, there will be then all the code will be then there will be a trigger whenever somebody places something on the Git, like the developers places some changed code or new code. So the trigger, it will trigger the pipeline, and the pipeline will take it to the Sonar cubes for the quality check of the code. There are so many things we have discussed earlier. And after the Sonar cube has permitted that everything is okay, the code has to be built. If it is a Java application, it will be used Maven. Maven will be the build tool over the build server. So there will be a build environment where the pipeline will take the code over onto the build. So there will be a build. If it fails, it will go back to the development team because to check something which is not properly so on the code. So again, the developer will correct the code and put that over the Git. Again, the trigger will be fired, and again it will go over the pipeline into the build phase. It will be built with the build tools. If the build passes, it will go to the testing for the SIT, okay, using JUnit or Selenium or XUnit. So many other testing tools are there. After the testing is 100% through, it will be released. So the release pipeline will come into picture. There will be a mechanism of release, like there will be permissions, there will be approval from the managers, from the test managers, from the project managers, from the operations manager. And after that approval, it will be released with a package. The package will be released. And then the package will be, I mean, the application will be containerized over the Docker engine. And then it will be deployed onto some environment which has been created by Terraform or an Ansible along with Kubernetes. So your application now resides in a production environment which is on Kubernetes. And if there is a constant monitoring and feedback, monitoring and feedback. So the monitoring will see whether the health of the application is fine, performance is not coming down, and all those sort of stuff using these tools. But the entire thing is applicable and available over the pipeline. So it is the pipeline which manages the entire information feedback, and so the automation is basically because of your integration with the pipeline, CI/CD pipeline. So you have to do one capstone project whenever we teach our students over the course, the full-fledged course. Then there is uh, 5 to 6 sessions of a project, okay, and where we will integrate all the tools that whatever we have learned so far, and through some capstone project we will deploy an application, and over Kubernetes and Terraform and Ansible, we will see that the entire thing is automated. Entire thing will be automated. So that is, it needs a rigorous hands-on and everything. It is not very simple. I mean, it is not over a fortnight that you can learn all the tools and can conduct a capstone project, or you can be involved into a project. It is some good number of hands-on practices. Almost like in our session, our main courses, we have DevOps for 2 months. That is almost more than 2 months. It can be between 8 to 10 weeks, almost 80 hours of sessions, and out of which 80% is more than 80% is your hands-on. Anyway, it is very difficult to over a 2 hour session to discuss the entire scenario. So I have taken almost, like, this is the 13th session. Okay, the other 12 sessions I have taught about the cloud, AWS Cloud. And another thing is the AWS and Linux. These two are outside DevOps. These are not DevOps tools. But to be a DevOps engineer, you need to know cloud very well. Any of one of the cloud. That is, you need not need to know all the clouds, but one of the important clouds like AWS or Azure or Google, that will do. And of course, you need to have a good knowledge on Linux, the operating system. Other tools will follow, but other tools are DevOps tools. But these two, your fundamentals should be very, very clear on cloud and Linux. So the DevOps journey basically is starting from the fundamentals of DevOps course. So all the tools that you need, at least 7 to 8 tools that we learn from each one of the phases, from each phase, one tool. Then we go for advanced DevOps and SRE. Okay. So SRE is a very, I mean, it's coming up, not only coming up, it is already there for the last 4 or 5 years now. So system reliability engineering, okay, which also will include the Kubernetes course. So basically, we have combined the advanced DevOps with the fundamentals of the DevOps in our course. Not, of course, we are not doing the SRE. SRE is basically there are 3 tools. There are 3 important tools. The search, log stash, and Kibana. So these 3 constitute basically this is a tool for the operations team. They will monitor the logs because see, once you have deployed it on the production, the next important phase is to monitor 24/7 the running of the application. And it is very difficult for operations guy who are not technically that good to always keep on monitoring the logs, because logs are the place where you get what is happening in the background. But so there are SRE tools that can be easily mastered by the operations guy, and they can help monitor the entire system, what is going wrong where, and immediately there is a Kibana dashboard, graphical interface to see what is happening, because you are dealing with hundreds and hundreds of microservices deployed over Kubernetes. Okay, so anytime, any particular pod or a container can go down, can be overloaded, can be performing very badly. So how do you know that? You need some advanced tools called SRE. Now, once you have more or less, I do not advocate you need to know SRE because that is mostly for the operations guy who are in the operations team. But as a DevOps guy, you need to know fundamentals of all the tools, I mean between 7 to 8 tools. And of course, you need to know Kubernetes. If you know this too, then you can graduate because you are the person who is good in DevOps. So you have created assets, resources using DevOps tools. And then thereafter comes the next stage, which is DevSecOps. That means you have to secure your assets. So basically the cyber security. But if you try to jump directly into DevSecOps, learning DevSecOps or cybersecurity, it doesn't help because you are lagging on the knowledge of these parts. So most of the companies who have implemented DevOps have gone for DevSecOps. Okay, you will not find any company which is directly doing cybersecurity DevSecOps without having implemented DevOps in their own organization. It is like they are intrinsic. I'm not going to this, but this is the demand according to the top 5 skills in demand. First of all, it is the Linux. As I told you, your knowledge on operating system is a must. Then comes Docker, and then comes any shell scripting. That means let's say Bash. Okay, that is if you know Linux, you might be knowing shell scripting. So whatever code that you write over the pipeline to make the pipeline automated, to integrate, everything is based on the shell. So shell is a very important part. Next comes Kubernetes. And finally comes the cloud. So if you master cloud, Kubernetes, Bash, Docker, and Linux, you are actually much in demand in the market. And you know the development or people coming from the development background have a maximum demand of 23%. Next comes people who know DevOps and SRE. Next comes the manager. It can be a project manager, it can be a DevOps manager, it can be a Scrum Master or whatever. So some sort of a management of, you have to have a knowledge of all these things. You have to have a development background. You have to have a knowledge of DevOps or SRE, and then you are a good project manager, technical project manager. So 18%. And finally, the operations team. The demand is less, and especially with the advent of AI, testing and operations have got a big hit. But these areas are not affected that much as what operations used to be having a huge demand earlier, 5 years back. But now you see it is only 9%. So coming to Kubernetes, it is designed by Google. So you can rely, and you can most importantly have a confidence of this product because it is going to stay in the market. Because the product is itself very futuristic. It encompasses all the technical benchmark which is required in this current scenario. Because it is designed by Google, it is kept on updating, and currently maintained by the Cloud Native Computing Foundation, that is CN, Cloud Native Foundation, CNF. That is the body, like you have the consortium called WWW, which is the governing body for anything that is any applications over the web, World Wide Web. Similarly, for any sort of Kubernetes sort of an architecture or something which is deployed over the cloud, it is governed by Cloud Native Computing Foundation, CNF. And that is because of this, you can trust and rely on the product called Kubernetes. It is an open source container orchestration system. Container, what is container? It is basically Docker based, all the applications which are containerized. And how do you orchestrate? Because when there are hundreds of musicians in an orchestra, will it be easier to synchronize? No. So you need someone, the maestro, who conducts the entire orchestra, who is standing in the middle, okay, with a stick on his hand, and he waves his hands and do all the notations and everything, so that all the musicians in that orchestra who playing various different musical instruments, they are all in harmony with the music. Not a single string is struck not in harmony, not in synchronization. So that is what you need. So if you think of each of the musician as one application or one microservice, so hundreds of microservices working together, creating one music, that is, and conducted by one maestro, like you have heard Jubin Mehta, Philharmonic. Okay, so that body is Philharmonic. So, and he's the maestro conducting the entire orchestra. So similarly, you think of Kubernetes is the maestro conducting the entire containers or hundreds of containers working as microservices applications into one single function. And it also helps in automating application deployment, scaling, and management. So you do not need to worry if your load on the applications increases, you will scale up the architecture automatically. Kubernetes has that power. Deployment becomes automated, and the management is seamless. Something is failing, even it will have the mechanism to restore it back. We will discuss all those things. So what can Kubernetes do? Why do we learn Kubernetes? So it is instrumentality deployments and rollout management. This is Kubernetes is mainly for rolling out management of deployments. So within the Kubernetes, you can describe a manifest file called deployment. Okay, you will write a code to deploy. So deployment as a code as a deployment. Like you create an infrastructure over Terraform, that is called infrastructure as a code. You will manage the configuration through Ansible, so it is configuration management as a code. Similarly, you can write your deployment, code your deployment through Kubernetes very simply. And also you can do the deployment roll out and roll back. Automated roll out and roll back. So basically, this is Kubernetes is used on these two functions, very important functions, because today's customers do not want any downtime of their system. So you need to have a blue-green deployment or canary deployment. Okay, because today's customers cannot tolerate downtime. Can you think of Amazon or Microsoft coming down for 1 hour or for a day? Billions and millions of dollars will be lost for their business. So nobody wants to deploy a new version or a upgrade by making a downtime of the system. It has to be, your system must be up and running, whereas you deploy parallelly without any
So we
knowledge
had
of
a
the users.
Cloudflare outage
Sorry.
recently. I'm saying we had a Cloudflare outage recently.
Yes. So can you think of Amazon.com or the Amazon.in? So which is a e-commerce platform of Amazon, like the Flipkart. Flipkart going down for say 1 hour. There will be a huge outage and huge hue and cry, because many customers are stuck. They were doing some important transaction or some buying, some operations were going on with the purchasing. Okay, you were putting in some money to purchase something, suddenly entire thing got stuck or down. So can spell doom. Millions and millions of dollars will be lost within a span of, say, even if it is 1 hour downtime. So therefore, I need to upgrade my features. I need to have include new features into my system, but without making my system down, or rather our users should not, millions and millions of users are logged on at that point of time when you want to upgrade something. I will not disturb a single user, so they should not find any outage. Okay, whereas at the same time I'm doing a deployment at the same time. That is possible because I have a Kubernetes implementation. I can implement a blue-green deployment. We have discussed that these canary deployment, blue-green deployment, flagship deployments, okay, on-off deployments. All this we have discussed earlier in other internship sessions. Resource bin packing. So you declare that for this particular resources to be run, what are the resource requirement whenever I will use any deployment, or whenever I will configure something which is required for configuration of a pod. Pod means a container. So I will declare how much CPU and memory will be required. So this can be automatically defined through Kubernetes. Inbuilt service discovery and auto scaling. See, the main issue of a big system is, and the system is not we have a concept of that the system is concentrated in one place. No, that was a monolithic application. as a client server application. No, we are not into client server application anymore. We are onto clouds and heterogeneous clouds. The clouds can have a mix of on-premise data centers as well as a mix of clouds. And the clouds can vary. You can have more than one cloud into your operations. Like you can have AWS Cloud as well as Azure Cloud. You are extracting some best features of some AWS Cloud, and also at the same time you are taking the best features of the Azure Cloud. So best of both the worlds. So it's a complex system. You are not, there is no sort of monopoly of a particular platform over the other. You have to have a heterogeneous system because one system cannot deliver all the goods. You have to hire other systems which has the best features. So you combine all the best features from different systems. So in that, it becomes when the system becomes very complex now, and it is almost distributed all over the world. Now your application is not concentrated in one place, like not in only one server. It is distributed over 500 servers all over the world, like Amazon. Application like Amazon. Amazon is getting used by billions and billions of customers all over, spread all over the world at the same time. So do you think that it is only catered by only one server in one place? No. It is spread over the cloud, and the cloud is spread over all over the world. So in this complex environment, if you want to search for a particular service, for a particular application, over thousands of applications spread all over the world, it is a difficult proposition. Who will come to your rescue? It is Kubernetes with its services. It will expose your containers. We will see later on that how you wade through the entire mesh, the jungle of services, and go to your particular endpoint. So managing the endpoint. So I say this is the cloud, and it is, say, in one region. There can be hundreds of other regions, so many other regions, several regions, and your application is distributed. Your application is microservices in one region. Then there is microservices in another region. They are all the same application, but distributed in microservices. So these are called containers. Or I will use a new term called pods, which is more Kubernetes aligned to Kubernetes, pods. Within pods, the containers are there. And within container, what is there? And can anybody tell me? So if this is the pod is the outer layer. This is the container. What is inside the container? So this is pod. This is what? This is the container. So what is this? Can anybody tell me what is inside the container which is running? Which is running? What should be running inside the container?
An application or a program.
An application, yes. So the application, let's say that is a .NET application or a PHP application or a Java application or a C++ application, whatever it is. So this is an application, but it cannot be a compiled application in such a form. Yes, it has to be a compiled application, build application, but it has to reside as an image. You have containerized your entire application as an image inside the container. And that image is running because it is inside a container. A container is a dynamic object, a runnable object. So image inside container, and container is inside a pod. Because pod is important to Kubernetes. Container is important for the image. And you have deployed the pod over the, this is the Kubernetes cluster. So let's say this is a Kubernetes cluster. This is a Kubernetes cluster in another region of the same cloud. Maybe this is an AWS cloud. And this can be an EKS cluster. EKS means Elastic Kubernetes Services Cluster. So it is this services are provided by AWS Cloud. So most of the management, service management will be done by EKS. You have lesser things to do, but these services are costly. But anyway, but the features or the advantages that you harness out of this services is fantastic, unimaginable. Automatic scaling. Okay, automatic health checkups. So anytime and this pod can go down. So immediately this is available and to the knowledge of Kubernetes. Kubernetes will make a replacement. If this is down, because this application is down, it will immediately replace this pod within no seconds, within seconds. So your application keeps on running. But let's say, so these are so many, there can be hundreds and thousands of microservices running all over the world as part of one big application, okay, enterprise application. Now you are in India, sitting in one corner in Kolkata. And within Kolkata, you are sitting somewhere in a very remote area of Kolkata. Doesn't matter. And let's say this is US, this is Japan, this is Australia, and maybe there is another sort of data center or cloud implementation over Africa. Sitting here, you need to access India, from Kolkata, from a remote area. You need to access. This is one big application. It is not that they are different. They are different pods running as microservices, but they are giving the same sort of application for every other user. Now, for India, maybe Japan is nearer. Okay, so I will automatically, I do not know where I'm going leading to, but I need to access one application which is residing in Africa. So this application I need to access. So I need to discover this. It will go through all this and go and come to this particular, because it has an endpoint. I have given an endpoint over my URL of that application, and this endpoint points to this particular service. So how do I go? Because these Kubernetes clusters are very, very secured. How do you go and reach to this particular application is the whole story all about. So this service discovery. So let me, for the time being. So this service discovery is the most important, one of the most important features and functions of Kubernetes. And also, when you auto scaling, so you have been accessing, and today there are 10,000 users. Tomorrow there can be 1 million users. So as your application is stretched, okay, you need more and more resources to be able to cater to Today it was 10,000, tomorrow it will become 1 million users. So you have to expand your resources. But will you keep on monitoring and managing and this thing? Is it not automatic? Yes, it should be automatic, because I cannot, by human means, it is most difficult to manage my resources as and when it is on demand. It has to be on demand. Whenever there is a demand of some more extra CPU or vertical scaling or horizontal scalings, that those scaling issues needs to be handled by the system, not by you. However expert you might be as an operations guy or a or someone who is monitoring the system, you will fail at there is a point of exhaustion. You cannot monitor thousands and thousands of applications running all over the world, however big your team might be. So there should be some mechanism, automatic things, that if I need some resources at that point of in the midnight, I need some scaling up, that will be managed by Kubernetes services, auto scaling services. I had to do only the configuration, that for this Kubernetes cluster, this configuration will like this. It can go up to this much of GB of memory for particularly for type of deployment of pods. Okay. So all these things will be managed by by Kubernetes. Kubernetes will mechanically expose your containers to the web or alternative containers within the cluster. It will mechanically load and balance the traffic. So there is a load balancing capability of the Kubernetes architecture. It will load balance the traffic across matching containers. Kubernetes supports service discovery via atmospheric variables and DNS. Out of the box, you will conjointly stack together CPU-based auto-scaling for containers and inflated resource utilization. So whenever there will be a resource crunch, you do not need to worry, because you have configured your cluster in such a way that it will be automatically, either it is CPU-based or memory-based auto-scaling will happen automatically. It can cater to heterogeneous clusters. Kubernetes can run in any place. You will build your Kubernetes cluster for a combination of virtual machines running on the cloud, on-premise, as I told you, or blank metal, bare metal, you can say, in your data center. So it can be a combination of cloud, on-premise, or bare metal in your data center. You just have to give the composition. That's all in the configuration. And persistent storage. You need, the pods cannot store anything. So who will store? It is the Docker volumes or the persistent storage. It is called you will claim the storage by PV and PVC. You store it through PV. PV is persistent. These are all features. Persistent volume. And then you claim it by persistent volume claim. These are the two features, very important features of storage in Kubernetes. And that can be persistent in anywhere in the cloud. And there are lots of services by Amazon or any other cloud provider, like Google Cloud Platform, persistent disk, Amazon Net Services, East by South. So many support for all these persistent services. Or you can use the Kubernetes core native storage services called PV and PVC. So you can use the cluster federation. Federation is like you can have a combination of various clusters within a region or spread across the regions. Okay, and that is supported by Kubernetes. High convenience options are there. That's why Kubernetes is already so popular and used by almost all the organizations who have implemented DevOps and CI/CD pipelines and have a lot of microservices applications to be on Kubernetes. So Kubernetes has seven use cases. Why the industry has adopted Kubernetes? Why industry has adopted Kubernetes? Kubernetes is like K, and these are the 8 characters S. So Kubernetes is also called K8S. K and S and 1, 2, 3, 4, 5, 6, 7, 8. K8S in short. 7 use cases. It is very simply to bundle or package the app within the Kubernetes cluster. That is the simple application use. Microservice, orchestrating complicated apps based on microservice architecture with many components. It can be easily done over. So it can this Kubernetes architecture can easily handle and orchestrate microservices application deployed over pods or containers. Lift and shift. So you can anytime. So this is a server on premise. You can lift and shift it over the cloud with the help of Kubernetes. I mean, it is not physically lifting it and putting it on the cloud. No. So you can, along with the application and everything, with the environment and everything, you can just migrate it over the cloud using the help of Kubernetes. So Kubernetes facilitates the moving of on-premise applications to the cloud. And this is a cloud native network function. So CNF based architecture, which is very stable and supported. The support will never end. Machine learning. So big applications having machine learning utilities, managing machine learning workflows to deploy faster AI-based apps. So they require a huge sort of resources, and those can be catered because it has an auto scaling features and everything. So as per the AI specifications, it can be easily deployed over Kubernetes. Heavy computing, it can support Hadoop databases like petabytes of data. 1 petabyte is 1024 gigabytes. And 1 gigabyte is 1024 megabyte. And 1024 kilobytes, 1 megabyte, and 1024 bytes. So you can think of the huge, it is, sorry, 1024 gigabyte is 1 terabyte. So petabyte is 1024 terabytes. You can imagine how big these petabytes are, and it can process hundreds of petabytes in one go. So because it is based on Kubernetes, it can auto scale and everything, enable computing heavy tasks. And it can be integrated over CI/CD pipelines easily. CI/CD task, CI/CD means continuous integration, continuous deployment and delivery. Tasks or the pipelines are easier to perform with Kubernetes. So that's why you will see on the pipelines, you will deploy Kubernetes. And on Kubernetes, you will deploy the applications. and the applications are bundled with Docker, packaged with Docker. So all the popular architecture and everything is enabled, is supported. So the role of Kubernetes, because now the movement of application has been from monolithic means one layer application to microservices. So you need containerization and orchestration of the containerization. So need of container orchestration from the monolithic. Monolithic is like a one layer, single layer. You have the front end, you have the back end, and you have the database, all within one layer, one application. They are tightly coupled and not independent. If something goes wrong in the database, back end will not function. Back end will not function, front end will not function. For a simple something gone wrong in the database, or something gone wrong with the backend, a simple function has gone wrong, no one will work, because they are very, very tightly coupled. This is called monolithic application. Whereas microservices application is, you have the front end, you have the back end, you have the database, nothing as microservices. And there are many microservice functioners in the line, in the queue, you can deploy it. They are all independent. But at the same time, this microservice can talk to this microservice can talk to this microservice. They are all interlinked, but they are at the same time independent. Okay, so you see, they can talk to each other, but at the same time, if this is down, this will still continue to run. If this is down, backend is down, this is going to run, this is going to run. Okay, so because they are independent microservices, they are not dependent on each other. But yes, when everyone is running fine, they will talk to each other and do the functions together. And therefore, whatever this, as I told you, this is a pod or a combination of several pods, the entire database. But your database is stored with the storage and persistence. So somewhere differently, not on the database. So if this pod goes down, your data is safe. The data does not. So this pod, if down, will be immediately replaced by another pod. But your data is always safe. This is not down. Okay. Any questions so far? No questions? Are there any people? Are there still any people? At least one? Let me check. Oh, there is less, but it's fine. Okay. Thank you. So let me continue. So we continue with the role of Kubernetes. You understand the need for a container orchestration tool. So the need is for a Kubernetes tool. This container orchestration is nothing but a integrated software called Kubernetes. From monolithic to microservices, increased use of containers, because we nowadays use containers because we use microservices. Mostly all applications are converted from monolithic to microservices. So we are not into a client server architecture anymore. We have a lot of other dimensions to this. Yeah, maybe the underlying architecture is client server, but actually the server is, the client can be on the cloud, the server can be on a different cloud, and the database can be on a different cloud. So many layers to this basic architecture, because we are using easily deployable microservices as containers. We do not have to port the application like earlier when you used monolithic applications. You have to port, you have to create the same sort of environment like you had done in your own server. No need. You just lift and shift, as we have seen. Okay, you pick up a pod and put it, because the environment itself within held within the container. As I was discussing in the Docker discussion, we have discussed how the environment is inbuilt. The environment that supports your application to run is inbuilt within the container. So I do not have to manufacture an environment separately for porting this application. No need. I will just pick it up and put it into any place, any server, any cloud. So microservice, whatever the microservice A, B, C, D, N, and Z, all these are part of. So maybe this is a login application. This is a product catalog. They are part of the same application. One big application, let's say e-commerce application, e-commerce. And don't think that they are in one server or in one cloud server. No, they can be hosted in different servers across the cloud. Or it can be a heterogeneous, as we have seen. It can be on-premise. This microservice may be on-premise. This microservice may be on a bare metal, and this microservice can be on a cloud. This microservice can be on a different cloud. This is AWS Cloud, and this is Google Cloud, but they form a part of the same. So the architecture, the cluster of Kubernetes will enable that they are tied as within the same application, though the platforms are different. Doesn't matter. It is the responsibility of Kubernetes to find the services where they are. Discovery, service discovery is the headache of Kubernetes. They can talk to each other, but at the same time, they are independent. If this goes down, it will not impact. They are still running. All these are running. And don't think that it is down means it will remain down. It will immediately be replaced. It will be immediately replaced by another one, another pod or another container. So what are the features the orchestration tool offered, that is the Kubernetes offers, is high availability. So it is not possible to say that your system is down. There is no downtime, because all your applications will be available 24/7 and 365 days if you consider the service to be running for 1 year. Scalability or high performance. So whenever your performance is getting down because of lack of resources, so it will be automatically be scalable. And that feature is provided by the services from Kubernetes. Disaster recovery, backup and restore. So if something has gone wrong, very bad, network failure, something has gone wrong, there is a mechanism to recover it from the disaster. There is always backup. The backup goes on in the background, always. This is the RAID application, redundancy. So something is always sleeping. And whenever the main system, the master fails, the slave will take up. So there is always a backup, and there can always be a restore. Now today I will go into these two part, and then we will end the discussion. Then we will take it from the next day on the architecture on the various components. Okay, but today we need to understand a bit of the architecture, how things are done inside Kubernetes. Is that fine? Any questions before that? Okay, so this is the Kubernetes cluster. The entire thing that we see over here is one Kubernetes cluster. This is the Kubernetes. This is the logo of Kubernetes. It is like a handle, the steering of a ship. Why it is steering of the ship? Because this steers all the containers loaded on the ship. So this is a ship. And these are the containers. You see, you will see the containers in the ship getting from one port to the other. And there is the captain of the ship holding the steering of the ship. And that is the maestro, the orchestra maestro. And these are the containers. These are the applications that you are microservices that inside the containers, the images, which is getting carried by the ship. So this is the logo, a very appropriate logo. So this is the Kubernetes cluster. There are two planes. One is the control plane, the master node, and the data plane, the worker nodes. This is called the master, and this is the slave. The worker node, slave, or better to say worker. This is the boss. Okay, so this is one server, worker node 1. This is one server, and this is another server. Both are working in a cluster managed by the master node. So these two worker nodes, there can be, if there are two worker nodes, so it is like this. Master, this is the master, and this is the worker node 1, worker node 2. There can be, and a thumb rule is one good master node can handle 40 worker nodes in a Kubernetes cluster. The thumb rule, the TR says that you should not, if the number of worker nodes goes above 40, you must consider a second master. Anything going above 40, because you have to also think of the performance factor for this master, which can handle, even if it's a big cluster, you should segregate out. You make multiple masters, because one master should not handle more than 40 worker nodes. Is it clear? So this master has few components. I will describe these components. And the worker nodes, which is reporting back to the master, will have these components. Now, coming to this part, HCD, this is called the key value store. It is sort of a database. This is the database of the master, and this is the API server, which is called, this is the heart of the cluster, and this is the brain. If you think that it's a body, this is the heart, this is the brain, everything is important. This is the scheduler, and this is the controller manager. So basically the controller manager will be like this in front of your the master node, and everything going out from this master node and everything coming inside this master node from outside is through the controller manager. Okay, so let us take up a case. What is the API server doing? API server is any instructions that are coming from outside. As you are a developer or you are a DevOps guy, you are issuing some commands through kubectl. So this is a component which you have to install when you are installing this cluster. This is interface kubectl, Kubernetes controller, Kubernetes control. So where you are, it is sort of a CLI or API, but it is not a graphical dashboard. It is you are writing the commands. That commands are the kubectl commands, that are Kubernetes commands that are coming inside and getting interpreted by API server. So processed by API server. Now API server can get the help of the database. What does this etcd database do? It will store all the cluster related, Kubernetes cluster related information over here. All the information. So API server will access this information, all the important information stored in the etcd database as a key value store. Key value store is like a JSON store, JavaScript object notation. That is, it's a key colon value store. So key is the reference or sort of a variable, and the value is what is stored inside the. So you are referring to a value through this key. Okay, so each of this information, whatever is there deployed over in this cluster, what is happening, whatever is happening will be available, should be available in this database, and API server will refer to this. And then API server will instruct the scheduler to do something over onto the nodes, onto the worker nodes through the controller manager. Now let me take up a case. Okay, before I do that, let us explain the data plane, the worker nodes. So whatever the application or data or anything will be residing, nothing should be residing on the master node. All the application level APIs, data, everything should be there inside the container. So there is a container runtime environment, CRI, container runtime interface, which may be implemented through Docker or Rocket or Mesos. But Docker is very, very popular, so we will always think of Docker. So through the Docker engine, the CRI, container runtime interface, we have implemented the pods. Pods are nothing but, as we have seen, these are the containers. The abstraction layer over the container is the pod. We will see that. And what happens inside the container, there is the image, the application running inside the container. So let's say this is a Java application. The same application is there a replication. This is replicated. Replicated means the same application is having two more replicas. This may be the original one, and these two are replicas. So whatever is available over here is available over here is available over here as an application. And this is available on the worker node, never on the master node. So we have deployed these pods onto some server acting as a node in the cluster. And this node will respond, is connect to the joined. Basically, it will join the cluster by joining what? The control plane, the master node. Then you say you have a one master and two nodes. It can be one master, 20 nodes cluster. So each of these nodes is joined to the master. It is one way. Node will be joining the master, not the other way. This is not correct. A master should not join the node. A node will join the master. Clear? To make it a cluster. So if there are 100 nodes, 100 nodes will join the master. Okay. Then it will form that there is 20 nodes versus one master. So similarly, in this worker node 1 and worker node 2 is joined to this, have joined this cluster by joining the master node. And each of these will have the pods or the applications deployed over containers. Now, this is Kubelet. Kubelet is the manager. Kubelet is the Kubernetes cluster, one of the components of Kubernetes, but on the worker node side is the manager. These are Kubernetes objects. So these are manifest files. Many objects can be there. One can be PV, one can be PVC. All these are available on the worker node side. Config file, secret file. So all this deployment file, all these will reside on the worker node side. But managed over the control plane. What is kubeproxy? Kubeproxy is another manager, but this is the network manager. Network manager. This is another component of Kubernetes on the worker node. So Kubelet is basically a pod manager. Pod manager. What does that mean? That means whatever is the state of the health of the pod and the management, he's the manager. This Kubelet is the manager of all the pods or the containers running within the worker node. Anything happening to them will be first reported and managed by Kubelet. Similar is the setup over here. This is one node, worker node. This is the kubelet, the manager of the pods. This is the kubeproxy. Kubeproxy is managing all the network related items, network related events. Can you see the arrows are pointing to the kubeproxy? So somebody, the end user will interact over the worker node through the kubeproxy, the network element of the Kubernetes cluster. Okay. Kubeproxy will communicate with the kubelet. Okay. Let's say I have a Java application running over in 3 replicas of or pods, 3 pods or 3 replicas implemented through some deployment or whatever that manifest file, some manifest file that has created these pods and running allocated resources and running in worker node 1 and worker node 2. Suddenly what happened is that this pod has gone down. It can happen. It's a system can go wrong. So this pod has gone down. Well, how will this be managed? Can anyone tell me? Who will first interact and understand that something has gone wrong? Who is the person? Will that information be automatically readily available to this control plane? No, it cannot. There should be some mechanism of how it will be communicated. So who is the first person to know that something has gone wrong over this pod?
Kubelet.
Proxy.
Kubelet.
Yeah, kubelet. Sorry. Yeah.
Yes, kubelet. Because kubelet is the pod manager. It is always keeping a vigilant. It is very much vigilant. It is monitoring what is happening over the health of the pods deployed over in this worker node. So kubelet will get the first-hand information that pod will be having some label. That is, during the deployment of this pod, those things will be written in the manifest file of deployment. Okay, so it knows that this particular label has gone down. So this pod has gone down, or this pod is not responsive. It is not behaving correctly. It is performance is down. Something has gone wrong, not up to the level. So this information is understood by kubelet. Kubelet will pass, or rather take the help of kubeproxy, because this is the network manager. So kubeproxy will let this information go to where it will be passed on to the controller manager. This component. Hello, any question?
Yes. No, sir. No question.
Okay. So the kubeproxy will take that information, what the kubelet wants to convey to the control manager or the master node is to be conveyed through the kubeproxy. Kubeproxy will take that information, put it onto the controller manager. Controller manager will put that first. It will be processed by API server. So the API server knows that, okay, one of the pods in server worker node 1 has gone wrong. That is the information that has been conveyed to me. I will check with my etcd. So it will go and check the etcd to find out on this worker node how many replicas were supposed to be on. So it will find that information that on that server or on that node, there are supposed to be 3 replicas running at the same time, up and running. So the information came that there is only 2 is running correctly, and this particular level, this particular endpoint, or this particular pod has gone down. So what is the message conveyed? There are 2 pods running, 1 pod is down. 2 pod is running. This information has come. It will recheck with the etcd and finds that it was supposed to be 3 up. For this application, for this type of label, for this deployment, I know that etcd has the information that it should be 3. So what is missing? 1. So what will it do? It will ask. It will go to ask the scheduler to say that please help node 1 kubelet to recover 1 pod. It gives that task to the scheduler. See, the manager, it's a manager. Manager does not do anything on their own. They will only delegate the task. So, and as an ideal manager, it will pass on the task to the scheduler. Scheduler knows how to fix up this issue. So what will it do? It will give this information to the controller manager. So it will go to the controller manager because it has to go out through the controller manager. That is why it is called controller manager. Okay. So controller manager has one more component, component you can say, and that is called replication controller. So this is also a manager. Everyone is a manager. Okay. Scheduler will take the help of controller manager and say that I have a replication issue. So it was supposed to be 3 up and running, whereas now currently on that particular node, there are only for this level, there are only 2 pods which are running fine. 1 pod is down. So please help me get that 1 pod up and running. So that information goes to the controller manager, because it is something related to replication, right? Because the controller manager has another sort of subsets of other managers. We will see that. But let's say one component is this is a sub manager or assistant manager, you can say, who is reporting to the controller manager. This is the boss of this replication controller. Okay, so this has a capacity. This particular manager or this particular worker knows how to get the things corrected. So this information from the scheduler will pass on to the controller manager. Controller manager will pass on to a specific person called replication controller, who will now contact whom? Can anybody tell me? Because it has to reach this particular pod. What will it do? See, this is
Proxy.
all on the master server, on the master node. These are components on the master node. It has to come to the worker node, that specific worker node, which has that problem, not on this worker node. All this information is available because HCD has all this information. It has been passed on to the scheduler manager. Scheduler manager has passed on to the controller manager. Controller manager has passed it on to the replication controller. So replication controller will contact the queue proxy, of worker node 1. And the queue proxy will take that, whatever the replication controller unit, for doing something specific work, and contact queue proxy will now in turn contact kubelet. Kubelet will let the replication controller work on this node, on this pod, and the pod will be replaced by another pod. That is the function of scheduler. Through the replication controller, the scheduler has scheduled one more pod because this is dead. So this is down. It will make another pod with the same application, replica of the same application, because it is following the manifest file called deployment. They are so much logical, and the flow is so much well orchestrated. That is why it is called orchestration manager, container orchestration. So it knows which manifest file has corresponded or implemented these pods, and it will refer to this deployment and find out that this is the pod. This is the application which is residing inside this pod. So I have to make a pod with that application up and running. So in all, this is again the 3 pods up and running. And once the work has been done, this information will flow down back to API server through the queue proxy, and then it will update the database again. It is a complex route, and this is happening within fraction of seconds. Not even minutes. Fraction of seconds it takes. How much expert it is, how much synchronized they are. And this is not the case of only one or a single application. There are hundreds of such applications running over the various worker nodes. And within no time, this anything that is happening over the health of the pods will be immediately managed and rectified. And so when I issue a command to check the health of the pod, of the number of pods that are running, I will see that the three pods are still running. Yes, the pod name has changed because this is a new pod with a new name. The earlier pod has gone down, but with the same application running. So think of a user who was using this pod. So there's a traffic who was using this or accessing this pod. The pod got down. So the traffic was diverted. This all happening parallelly. The traffic was diverted to the other good pods, either this or this, without the knowledge of the user. Okay. And in the meantime, it has rectified this pod or made the other available pod. Again, the traffic will shift back. The traffic shifts back to this pod. And that load balancing will happen automatically within the, because that is done through the control plane, load balancing. So for the time being, it was shifted to another pod, working healthy pod. And then once it has been rectified, the traffic moves back to the original one endpoint. Is that more or less clear? So the end users who are accessing the pods through the kube proxy and coming to the kubelet, can you see? It is coming to the kubelet and kubelet going to this, accessing the application. So the end users were doing it. Something has happened in the meantime. But the users are unaffected. We have no issues with the user. User is transparent. The user does not know what has happened in the meantime. Any question? Did you get it?
Yes, sir.
How the traffic flows, how the things are automatically taken care. You are not even aware something has gone wrong and it was rectified immediately. That is the mastery. That is the magical thing about Kubernetes. I'm talking about a single of a very small application, only 3 replicas running on one worker node, but there can be thousands of replicas or rather applications which are running. But to understand it simply, I have taken a simple example. So I will, as I told you, this will be the last slide for today. So you can see, one more thing. I have not discussed about Cloud Controller Manager. There is a Controller Manager and there is a Cloud Controller Manager. Now, you have noticed I have mentioned that there could be an EKS cluster on AWS. So you have, see here, you have deployed your Kubernetes on premise or on your data center on a particular server. Okay. So that master node is one server that is under your control. But suppose you have, your company has decided that we are going to implement AWS Cloud EKS, Elastic Kubernetes Service. So that means what you are doing, you are deploying this cluster not on premise, but over the cloud on a service called EKS. This is costly software or costly service provided by AWS. Similarly, for Azure, if you are using Azure Cloud, you have AKS. AKS means Azure Kubernetes Services. These are called software as a service, SaaS. So they give you end-to-end services, SaaS applications, software as a service. Another A will be there. Software as a service. Similarly, AKS is also a software as a service, which is Kubernetes service called Azure Kubernetes Services. Similarly, for Google Cloud, GCP, Google Cloud Platform, it is GKE. Google Kubernetes Enterprise, which is also again a SaaS. They are having the similar, but EKS and EKS particularly has a lot of Kubernetes services. So you are going to implement EKS over the cloud, AWS Cloud, and then to interact with your master node, you have to have so automatically there will be a cloud controller manager implemented along with the controller manager. So this controller manager is definitely something which will I will monitor or control the traffic between the worker nodes and the master node. And of course, controller manager has all sub managers. Like one of the managers is replication controller, sorry. So cloud controller. So if you want to get into your Kubernetes cluster from using the EKS, you will use an interface. So cloud provider API. So anytime you want to take the services of EKS, you go through cloud controller manager. The API server will interact with the cloud controller manager, get the EKS services into the cluster and work accordingly. The rest, the same. So additional is you have taken SaaS services of EKS or SaaS services of AKS, and what is the interface? Interface is Cloud Controller Manager, another component. So it is grayed out. Generally, if you are not using this, you do not need this. But if you are using EKS or AKS or GKE, you will need a Cloud Control Manager. So whenever you implement this EKS or AKS or GKE, the Cloud Controller Manager component will be automatically installed into your master node of the cluster. Clear? Any doubts? The rest of the flow will remain the same. So only whenever you give a kubectl command to get EKS services to do some customized services, some specialized services on the Kubernetes, the sophisticated services are there, very, very sophisticated services and graphically available. So sometimes you do not have that much of CLI commands, which can get you all those services. So you can use the EKS or AKS or GKE. Fantastic services are there. That's why it is costly, priced, costly. But you are working under a big organization. So these organizations will have enough because they have large applications. So it will be better to go for EKS or AKS or GKE. So the enterprise or your organization, which is a medium sized or a big sized company, they will go always for EKS. Yes, they will rely on you, but aided with the software services that are enabled within EKS. Are you getting me? Otherwise, if you are doing all on your own, there are very good Kubernetes certified engineers, architects, Kubernetes certified architects. You have to pass all these exams. Okay, so to qualify as an architect. So a company can have a very 16 years experience, So there I may not need this EKS. So the company can save a lot of money by hiring one person who is a certified engineer with a lot of experience. So therefore, I can have the same sort of services, but through this person who can avail me all these services, but by doing all those configurations on its own. Otherwise, if you are not having that much of expertise in your organization, you can go for implementing this. Clear? So the last slide for us today is, I think we are almost done. Just you have seen the picture. You are the DevOps guy or a developer. You are writing kubectl commands. It will come to the kube API server. API server will either go to the scheduler manager or the controller manager or HCD. Okay, and then it will manage the pods through the kubelet and the system services. Container runtime is managing the pod, node 1, node 2. So sorry, this will be node 2. Okay, and then the end user can avail the services of a load balancer, cloud provided network edge. So you can be having a cloud provided load balancer, or you can implement a load balancer, or something that we will learn next day called, which is also which can act as a load balancer, is Ingress Controller, which you can, as a good Kubernetes knowledgeable guy, you can implement this Ingress Controller. It is less costly, very, very less costly compared to the network load balancer from a cloud provided. Say, let's say you are using AWS Cloud, then you will use a ELB, Elastic Load Balancer of AWS, which is costly. So if your company wants to avoid this, so we can go for Ingress Controller, which has wide, powerful features like the load balancer. So in that case, the end user can access the Ingress Controller, and the Ingress Controller will take you, distribute the load, and can go to a good pod in a good condition and can avail the services. Similarly, if there is a cloud provider, that means EKS, okay, some services that you have implemented over the Elastic Kubernetes service, then you can use the Cloud Controller Manager to get these services inside your control plane. Okay, and but again through your Kube API server, everything will be done through. So this is the most important part of your master node. Without anything cannot happen without the permission, like it is the president of the country. So everything will come to it and then it will be distributed. The super boss. So today I will end the discussion over here. It is already time. I hope you got something, not all. Of course, it is not possible. Okay. I will stop the recording. The recording has stopped, and stop the sharing. I hope you have enjoyed the session. So
Yes.
next day we will talk about the second part and conclude the whatever little knowledge that can be imparted on Kubernetes. Very good. Thank you, Shravani. So bye for today. We will meet again on next weekend.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Yes, thank you. Hello, Shubhro. Hello. Shubhro, acho?